Let us try to understand the characteristics of a rational function, visualize and then graph it. A test problem for you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will understand some characteristics of rational functions. We have taken a rational function where numerator and denominator are quadratic in nature. F of x is equal to 2x squared plus 7x minus 4 divided by x squared minus x minus 72. We need to determine the following characteristics. 1. When x approaches minus 8 from the right side, f of x approaches what? So you have to fill in these values. When x approaches 8, it should have been minus 8. From the left side, f of x approaches what? When x approaches 9 from the right hand side, from the left side, then f of x approaches what? When x approaches negative infinity, f of x approaches what? And then we have to find the intercepts, y-intercept and x-intercept. Now you can visualize that a rational function like this might have two vertical asymptotes. So it may be a good idea to factor both numerator and denominator and then answer these questions. Questions actually give you a hint. When you're trying to find the behavior as x approaches minus 8 or 9, it gives you an idea that there is a vertical asymptote at 8 and 9, and we want to understand the characteristic of graph. Perfect. So, I hope with this, you have enough knowledge to get into the solution. Try to answer and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is anil.anilkhandelwal.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. We can answer many of the questions directly also. However, I will prefer to first factor both numerator and denominator and then answer the question. So begin with factoring. Perfect? So here we have the function given to us. Let us factor both numerator and denominator. F of x is 2x squared plus 7x minus 4. We are looking for product of minus 8 and sum of plus 7. So we could write the numerator as 2x squared plus 8 and 1 can give you, right? So plus 8x minus x, that will give you 7x minus 4. And the denominator, you could factor directly. We have minus 72, 8 times 9. Since we have minus x, 9 will be negative. So we have x minus 9 times x plus 8. Now that explains you why there are vertical asymptotes at plus 9 and minus 8. Correct? Let us complete the factoring in the numerator. You can always take 2x common. And then you get x plus 4. Here we can take minus common to get x plus 4. Denominator being x minus 9 times x plus 8. So finally, I could also write this function f of x as equal to x plus 4 times 2x minus 1 over x minus 9 times x plus 8, right? So as soon as we get our rational function, we are in a clear position to say that x is not equal to 9 and x is not equal to minus 8. So at these 2 points, we have a vertical asymptote, correct? So we have vertical asymptotes at x equals to 9 and at x equals to minus 8, correct? Now we are trying to understand the characteristics. So all the characteristics you need to answer is what happens to the graph of the function when it is approaching some value. Mainly the values are the vertical asymptotes and that is the end behavior, right? So let's try to answer this question. Now I will be using this factored form to answer them. So as I said, the function here x is not equal to 9 or minus 8. But we can always approach minus 8. That's the whole idea. Now to find the behavior of the curve when x approaches minus 8, from plus means from right side. Do you see that? From right of 8. In that case, what happens to the y value, that is f of x? Will it go towards positive infinity or negative infinity? This is what we are trying to see, correct? Perfect. So what can we do? Well, if I have a value which is slightly more than minus 8, means, let us say, minus 7. In that case, what are going to be the signs of each one of these? That is what we are interested in, right? So we have to analyze this function. Let me rewrite this function in a different ink. So we are analyzing what happens to 2x minus 1, this factor. And the test point for us is minus 8, right? On the positive side, that means minus 7, right? So 2x minus 1, x plus 4, x minus 9, and let me write x plus 8 right on the top. So we have to analyze whether these points, these function values, the factors are positive or negative. As I take my test point, which is test point being minus 7. So that is on the right side of minus 8, right? So, of course, as I do that, x plus 8, if I put minus 7 for x, it is still positive, right? This will be negative, this will be negative, this will be negative. So in that case, overall, what do we get? Since there are 3 negatives, we get negative. That means that at this vertical asymptote, which is at x equals to 8, the function from the right hand side is going downwards. Do you understand? That is what it means. When x approaches minus 8 from the right hand side, f of x is approaching minus infinity. You understand? That is how we can answer this part of the question. Correct? Now, can you do the same thing for when x approaches 8 from the left hand side? In that case, what are you going to do? Well, let us use this space. So I am going to divide it like this, and this time I am going to use a point which is on the left of minus 8. So that point could be x equal to minus 9. Right? So that is when x approaches minus 8, but from the left side. You get the idea? So with minus 9, how the signs are going to change? Okay, With minus sign 9, this will be negative, right? And all others will also be negative. So all negative means we get into positive. That means f of x approaches positive infinity. You get the idea. So if that is the asymptote, then it is approaching positive infinity. Perfect? That is how you could visualize the whole thing. Does make sense, right? So let me rewrite. This will be minus, and that is to say that end, right? Perfect. And with plus, it is going towards this side. That is how we can answer this particular question. Clear? Now let's look into the second part of it, where we'll analyze the same rational function as x approaches 9 from the left side, correct? So clearly, what we are going to do, the factors for us are 2x minus 1, x plus 4, x minus 9, and x plus 8. We will take a test point on left side of 9, right? 9 minus means we could take a value of x which is before 9. Let's take 8, right? So if I take a test point 8, then what happens? We are taking plus 8, right? So in that case, this is positive. This is also positive. That is negative, right? And this is positive. So overall, in this particular case, it happens to be only one negative, and therefore, it is f of x is approaching negative infinity, correct? So we can write this negative infinity simply because when you multiply one odd number of negative, then we'll definitely get negative only, right? So it is going towards the negative infinity side. Does it make sense to you? Perfect. So that is how we will answer these questions. Now with this in mind, since we know the behavior, you can actually sketch a very accurate graph. I will leave that for you at the end of this exercise. Now, question number 4 is, what happens when x approaches minus infinity? I would like you to pause the video and answer this part, right? And also, here, I'm adding one component to it, which is what happens when x approaches 9 from the right side. Then f of x approaches what, right? So I'd like you to answer this question also. Perfect. Now I hope you got that one. Let's look into its solution. When x approaches minus infinity, and if f of x approaches a value, we say it as a horizontal asymptote. Those who are experienced doing these kinds of questions, they can always say that the horizontal asymptote exists and the equation is y equals to the ratio of the leading coefficients. In this case, it is going to be y equals to 2. Right? However, we'll use algebraic method to show it. Right? So here is our algebraic method. Very important. So how do we do it? So the idea here is to factor out x square itself from both numerator and denominator. So if I factor out x square, I get 2 plus 7 over x, right, minus 4 over x square. And denominator, we get x square factored out, so 1 minus 1 over x dividing by x square, right, minus 72 over x square. Now see, if that is the expression, then clearly x square cancel, right? Now, as x approaches a very large value, it could be negative infinity or positive, what happens to 1 over x? Well, 1 over x will approach 0, right? Similarly, 1 over x squared will also approach 0, right? Even 7 over x will approach 0, right? So you see that these components, they approach 0. So we're left with the ratio of leading coefficients, which is 2 over 1, right? And therefore, the answer is 2. You see that? That is how we find the horizontal asymptote, especially when we have both numerators and the denominator degrees exactly same. Perfect? So that's the strategy. So I hope this is absolutely clear. Now, let's get into the intercepts. We're looking into now x-intercept and the y-intercept. Well, x-intercept is a point where y is equal to 0, right? So y can be 0 when the numerator is 0. So we are saying f of x is equal to 0, and in the factored form, we have 2x minus 1 times x plus 4 divided by x minus 9 times x plus 8. So if I substitute y equals to 0, means numerator is 0, right? So this 0 should come from the numerator. So clearly, it applies that 2x plus 1 equals to 0, and also x plus 4 equals to 0, right? So that gives you the answer. 2x plus 1 equal to 0 means 2x equals to minus 1, or x is equals to minus half. Here, x is equal to minus 4. So these are the zeros or the x-intercepts for the given function, right? So we have the x-intercepts, which are at the point minus half, 0, and minus 4, 0. Make sense? So those are your x-intercepts in the given situation. Now, how about y-intercepts? To find y-intercepts, what we can do is we can just substitute x equals to 0. So let me change the ink. Y-intercept means x equals to 0, right? So if I write x equals to 0 in the function, I'm left with what? Let me do it on a fresh page, and we'll try to find what is the y-intercept. Okay. Well, this is y-intercept. So y-intercept is at x equals to 0. So basically, you're trying to find the value of the function when x is 0, right? So if x is 0, I get minus 4 over minus 72, correct? So that is what you get. So you can divide and write down, dividing 72 by 4, 4 times 1 and 18. So your y-intercept, therefore, is at 1 over 18. Clear? So see, that is how we will answer all these questions. So let's summarize. When x is approaching minus 8 from the right hand side, f of x was approaching minus infinity. But when you approach from the left hand side, minus 8, in that case, it was approaching positive infinity. For 9, left hand side, it was approaching minus infinity. And for minus infinity, that is a horizontal asymptote, right? It was a ratio 2 over 1, which is 2. So we should actually write y equals to 2, right? Y equals to 2 is horizontal asymptote. The x-intercepts are definitely when y is 0. So those were at minus 4 and at half, right? Plus half. 2x minus 1, right? So plus half. So I think I wrote minus half there. Plus half, right? Yeah, I made a mistake writing this term minus 1, right? So it is plus half. Correct. So that is how you can actually summarize everything. Correct. Now, I like you to sketch the rational function. Right? All the characters are given. So overall, you can see how it might look like. Right? So if I have an axis like this, we have two vertical asymptotes, one at -8, the other one at 9, right? And we have you need to find, here we have y intercept at 4, 1/18, right? The end behavior, x intercepts at -4 and half. So the graph is, let me sketch it roughly here, right? I would like you to do more accurate job. And something like this here, where the horizontal asymptote is at y equals to 2. You get the idea? So that is how the graph is going to look like. So I think the concepts are absolutely clear, right? So we have taken up this rational function, and from all these things, we finally figured out how this rational function may look like, right? So once again for you, the rational function will have two vertical asymptotes, one at -8, the other one at 9. We found that this behavior, when you are approaching 8 from the right hand side, you are approaching -infinity. From the left hand side, you are approaching positive infinity, right? As far as -9 is concerned, we approach -infinity, so it's kind of like this, right? As far as this infinity is concerned, we approach a value which was 2. The x and y intercepts were found at these points, right? The y-intercept was positive. Connecting these points, we get our graph, right? So the graph will really look like this. You see how, working on these parameters, we can very accurately sketch the graph. And these zeros, clearly from the factored form we got, this was as half and this was at -4, correct? 1/80, y-intercept. So that is how you have to deal with the rational functions. So I hope these concepts are absolutely clear. And the key here is that you need to factor and then answer the question. That will be best. So I hope you have understood the technique. If you have any doubts, feel free to send an email on the address given. You can also learn from me. Most of my students are doing fairly well. And so you can also join this success path. Thanks for your time and all the best.